Okay, in this lesson I'm going to be talking about logarithmic functions. Now, it's been my experience, a lot of high school students will have some exposure to logarithms when they take Algebra 2, and yet very few students normally remember much about logarithms. I think there's a few reasons for this, but one of the reasons is because of the notation. So for example, this is a question I'll ask students, and if you have a basic understanding of what a logarithm is, this is a very simple problem. And in a class, maybe I'll have one or two people that'll remember what that is. Maybe. Anyway, it looks kind of complicated, and it's certainly different than anything else we've done up to this point. I mean, we just haven't really had anything that looks like that. All right, so I would argue that the basic concept of a log is actually not that complicated. It's just a matter of understanding some basic things and also getting used to the notation. All right, so one of the things I would like you to do, actually before we do that, I would just say the first thing you need to do if you're going to be successful with logs is you need to make sure you know your exponents. Just doing basic exponent arithmetic. And so that's what you're doing on this first page. So I would encourage you to do every problem that you can on this first page and then watch the video, and let's see how you do. All right, so let's go ahead and look at this. We've got 2 cubed equals 8. Of course, that means 2 times 2 times 2. Of course, 2 squared is 4, and 2 to the first power is 2. Anything to the 0 power is 1. And then we get to this one here, and I would remind you of a property that we have for negative exponents. A to the negative n power is equal to 1 over a to the positive n power. And so 2 to the negative 1 power is just 1 over 2 to the positive 1 power, which is a half. And 2 to the negative 2 power is just 1 over 2 squared, which would be a fourth. So hopefully by this point you start to see a pattern. In fact, we know that 2 to the first power is 2, and 2 to the negative 1 power is a half, which is the reciprocal of 2. 2 squared is 4. 2 to the negative 2 power is 1/4. All right, so if 2 cubed is 8, then we know 2 to the negative 3 power is 1/8. All right, so similarly, 4 cubed is 64, 4 squared is 16, 4 to the first power is 4. Again, anything to the 0 power is 1. Since 4 to the first is 4, we know 4 to the negative 1 power will be the reciprocal of that, 1/4. 4 to the negative 2 is, let's see, 4 squared is 16, so that means this will be 1/16. 4 cubed is 64, so this 4 to the negative 3 power will be 1 over 64. So basically, with these negative exponents, I got a little phrase that I like to use. Negative exponents lead to reciprocals, not negative numbers. Oops, that should be negative numbers. So notice all of my answers here are positive. Negative exponents, normally when we think of a negative, we think in terms of the sign of a number. But negative exponents have nothing to do with the sign of our final answer here. They're all positive. All right, in number 3 it says, in the exponential statement, 2 cubed equals 8. So let's see if we know the parts here. The 2 is called the base. The 3 is called the exponent. And honestly, we don't really have a great word for the 8 there, so I'm just going to call it the answer. All right, so let's move down to the bottom. Yeah, we're going to keep it simple there. Let's see, what exponent do you put on a 3 to get an answer of 9? So we're basically doing this. We're thinking, what exponent do you put on a 3 to get 9? Of course, that's 2. And then on B, what exponent do you put on a 5 to get an answer of 125? That would be 3, because 5 cubed is 125. What exponent do you put on a 9 to get an answer of 1? Well, remember, anything to the 0 power is 1, so that would be an exponent of 0. Letter D. What exponent do you put on a 5 to get an answer of 1/25? Well, we know 5 squared is 25, so 5 to the negative 2 power would be 1/25. All right, let's look down at the bottom here. Now, I would imagine when you started doing these, you realize that this is really the same as what we were doing in problem 4. Really on letter A here, we're looking for the exponent on a 10 that gives you 100. So, of course, x would be 2. On B, 3 cubed would be 27, so x is 3. Let's see, 5 to the first power would be 5, so here x is 1. And we know 6 to the 0 power would be 1, so x must be 0 there. On letter E, we know 6 to the first power is 6, so 6 to the negative 1 power would be 1/6. On F, we know 3 squared is 9, so 3 to the negative 2 power. So if x is negative 2, that would work. That would give us 1/9. Now, usually students will get most of the problems up to this point, if not all of them, and then they get stuck here. Now, you may recall we had a property that said the square root of x is equal to x to the 1/2 power. In fact, fractions as exponents lead to radicals. And so in this case, notice, 9 to the 1/2 power would be the square root of 9, which is 3. And so our answer here is 1/2. Now, if you look at H, you can try all day, but there really isn't any integer or any nice number that we can take to 2 to that power and get 5. Of course, 2 squared is 4 and 2 cubed is 8. We skipped the 5, and there's nothing else that comes to mind. Now, you might have maybe used your calculator and you could play around and you find that it's a little bit more than 2 point something. I'm going to go ahead and write the answer this way because for now, it's the best we can do, which is not really all that impressive. And that is x is the exponent you put on a 2 to get 5. All right, so far that's the best we can do. We don't really have a way to solve this. In fact, if you had 2x equals 5, you would divide both sides by 2 to solve this equation for x. The opposite of multiplying by 2 is dividing by 2. If you had x squared equals 5, well, the opposite of squaring is taking the square root. You would take the square root of both sides. We don't really have an opposite for taking 2 to some power. And so that's what we're leading to. All right, let's move on to the next slide. So logarithms, it says, consider the last problem, 2 to the x power equals 5. The question here is what exponent do you put on a 2 to get an answer of 5? And again, there's no integer that works. We don't really have anything that works. In fact, we have no way to do this without a new function. This new function is the inverse of the exponential function. This new function is called the logarithmic function. So notice our definition here. It says the function y equals log base b of x. So the way we read this is log base b of x. Log base b of x, or sometimes people will say log of x base b. All right, so it says this is the logarithmic function with base b, where b is greater than 0. So just like when we were working with exponential functions, our base is greater than 0, it's positive, and it can't be 1. B is not 1. And then further it says y equals the log base b of x has the same meaning as b to the y power equals x. Now this is going to be very important here. So remember what I said a few minutes ago. Number one, if you're going to be successful with logs, you've got to know your exponents. Number two, you need to know this definition. In fact, I'm going to go ahead and put a star here. I got to be careful. I'm going to be using, we'll just put it like that. Because this is the second thing. We've got to know this relationship very well, because we're going to be using it a lot when we're working with exponential functions and logarithmic functions. So this is our step. Our second thing. If you're going to be successful with logs, you got to be comfortable with going back and forth between these two forms, logarithmic form and exponential form. All right, so I want to point out something here. We have b to the y power equals x. B is our base. Y is the exponent. And remember, we're calling the x the answer. So notice in the other form, in the logarithmic form, the b is a subscript. That's my base. The exponent, and by the way, I call the subscript the little guy. And then the y, which was my exponent, that is my exponent, it's all alone in this form. And notice the answer goes there. So it's very important, if you're going to be able to go back and forth between these two forms, that you know these three parts. All right, so for example, if you look at this first example here, it says log base 2 of 8 is equal to 3, means 2 to the third power equals 8. So 2 is our base, 3 is our exponent, and the answer is 8. In the other form, the subscript, or what I call the little guy, is my base. The exponent is all by itself, and the answer goes there. Now, there's kind of a slick way to help you when you're in logarithmic form to make sure that you're equal to the exponential form. So what I do is I start here at the base. So base, exponent, answer. So 2 to the third power equals 8. And so I call that round the world. So over here on the second one, so first of all, looking at the exponential form, we have 7 to the negative 2 power is equal to 1 over 49. So again, if you do around the worlds, you start with the 7 to the negative 2 power equals 1 over 49. All right, so around the world, when you're working with logarithmic form, might help you at least to check yourself and make sure you have the three parts in the right place. So these next two sets of problems are we're just going to practice going back and forth between the two forms. So on number 6 here, if we're going to change to exponential form, let's start here with the 5. It'll be 5 to the third power equals 125. And on the second one, 3 squared is equal to x. It's that simple. So if you haven't already, you might try doing 8 and 9. All right, on number 8, we have 8 to the negative 2 power is 1 over 64. And by the way, that is true, so that would be an indication that we've done this correctly. And over here we have x to the a power is equal to 8. All right, so now let's, on number 10, we've got to go. Let's see, it says write each equation in logarithmic form. Notice these are currently in exponential form. And so the first thing you want to do is write log, or just the log. Now our subscript will be the base, which we know is the 3. Remember, the exponent goes all by itself on the other side, and the 81, that would go right there. The answer goes right there. Now, again, to check yourself, actually, this is usually the harder direction for students to go. So notice you can easily check this using round the world. 3 to the 4th power is 81, and that is true. So again, I would encourage you, if you haven't already, to do 11 through 13, and then you can check your answers. All right, so here we have log. Our base is 16. The exponent goes over here, and the 4 goes here. And again, if you check it, you have 16 to the 1/2 power equals 4, and so that is correct. On the next one here, you should have log base 5 of 1/5 is equal to -1. So again, we have base, exponent, answer. And then on the last problem here, well, let's see, you have log base 2. Again, the exponent goes all by itself. The answer goes there. By the way, this is the problem we were doing earlier, and we weren't able to solve for x before. Notice we have now by just switching forms, although we still don't really know what this number is, but we're headed that direction. All right, let's move on to the next slide. So on 14 here, it says evaluate without the use of a calculator. Well, the thing about a logarithm is it represents an exponent. And it gives you all the information that you need to know to evaluate the exponent. So basically, this is the exponent. This logarithm is the exponent. You put on a base of 9 to get 81. In fact, this is exactly what we were doing on the first page of our notes. So what exponent do you put on a base of 9 to get 81? In your mind, you're basically doing this. And of course, that would be 2. All right, go ahead and try number 15 and then check the video. All right, so here we want to know what exponent do we put on a base of 2 to get 1/4, and of course that would be -2. We know 2 squared is 4, so 2 to the -2 is 1/4. All right, so you should try all of these up through 20 and then check your answers on the video. So here you should have said 3 because 4 cubed is 64. And by the way, don't forget you can always check these. 4 cubed is equal to 64. That's true. So you can do the round the worlds to check yourself. All right, on number 17, so what exponent do we put on a base of 8 to get 8? That would be 1. On number 18, what exponent do we put on a base of 3 to get 1? That would be 0. On number 19, what exponent do we put on a base of 9 to get 3? Well, we basically did this. This is 9 to the 1/2 power. Remember, 9 to the 1/2 power would be the square root of 9, which does equal 3. Now this one's a little bit tricky. You might want to go ahead and write this as log base 5. Actually, you kind of need to do this. This could be written as 5 to the 1/2 power. So remember, this is an exponent. It's the exponent you put on a base of 5 to get 5 to the 1/2 power. Well, that would just be a half. Now, let me do, so some of you, some people have a hard time seeing this the first time or two. You got to think about it, but it's actually quite simple. It's almost too simple. Let me go ahead and change this to an x. And remember, and so we need to solve for x. Let's say that, we want to try another way. So we can write this in exponential form. We know 5 to the x power equals 5 to the 1/2. So 5 to the x power equals 5 to the 1/2 power. And notice the only way that these two expressions could be equal is if x is a half. Since they both have a base of 5, the exponents must also be equal in order for the expressions to be equal. And so you do get that x is equal to a half, or this original problem, this logarithm is equal to a half. All right, let's move on and talk about common and natural logs. It says log, so it says here log of x, or we read that the common log of x means the log base 10 of x. And here with natural logs, this is ln of x. Notice it's not NL natural log. I think it has to do with the fact that it's for another language, log natural or something like that. But anyway, all to say this is the natural log of x, which means the log base e of x. And so here's the bottom line. For a natural log, we don't write the base and it's e. For a common log, or when we write a log without a base, it indicates, if we write log, it indicates that our base is 10. All right, so we're going to go ahead and do the rest of these problems, and the only difference is these are using one of these two special types of logarithms or bases. All right, number 21. So if you want, you could always put in the base here, which is 10, and now we'll do just like we did before. 10 to the second power equals 100. Base exponent answer. Base exponent answer. We know here our base is e, so e to the first power equals x. Or you could just say x equals e. Oh no, actually, we're writing it in exponential form, so we should put that 1 there. All right, so if you haven't already tried, you might want to see if you can do the other problems. Let's look at 23. So we're going to first want to write, since we're writing in log form, let's go ahead and write log. And I'm going to start by writing my base, which is 10. Remember, the exponent goes all alone, and the answer goes there. Now with fractions, we usually put parentheses around them. But again, with base 10 logs, we don't normally write the 10. So let me get rid of that 10. So we would write it like that. All right, on the second one here, or number 24, so this is a base e log, so this is a natural log, but I'm going to go ahead and just write log base e. The exponent goes all by itself over here, the answer goes here, but again, we don't write log base e. Now I can't just erase the e because that would be a base 10 log. This is a natural log of 1 equals 0. All right, let's look at number 25. So our base is 10. You might want to write that in. And again, a logarithm is an exponent. So this is the exponent that you put on a base of 10 to get an answer of 10. Well, that would be a 1. So here in 26, my base is e. So what exponent do you put on a base of e to get e? Again, you could do this. And of course, that's also 1. On number 27, again, I'm going to go ahead and write a 10 here. Now, let's see, 10 to some power is 0.001. I would remind you, 10 to the negative 1 is 1/10. So that's actually 0.1 or 1/10. 10 to the negative 2 is 1 over 100, or 1 over 10 squared, which is 100, which is 0.01. And so 10 to the negative 3 power is going to give us 1 over 1,000, which is 0.001, which is what we have here. So on 27 here, what exponent do you put on a base of 10 to get 0.001 or 1,000th? That would be negative 3. On number 25, what exponent do you put on a base of 2 to get 2 to the 5th power? That would just be 5. On number 29, what exponent do you put on a base of e to get e to the 5th power? Well, that would just be 5. All right, I'm going to go ahead and stop this video here, and I'll do a second video.